Hey guys, so this week we are doing triangles. I'm going to go over the notes like I do every other week and do some example problems and then send you guys the video. So, a triangle is a three-sided polygon. Which looks like that. A side is one of the line segments connecting to the vertices of a triangle. So if we have this triangle, ABC, this is a side. Your angle is your vertices where it's the interior measure formed by two sides. The leg is in a right triangle. So it's the sides adjacent to the right angle. So when you have a right angle or a right triangle, here's your right angle. This and this are your two legs. Your hypotenuse is also in a right triangle, and it's the side opposite the right angle. So that would be this side right here, it's opposite. A scalene has no sides that are the same length. An isosceles has two sides that are equal. So for example, those two sides are equal. And then also the opposite angles to the sides are congruent. So those are the same as well. Equilateral, all sides are the same. And all angles are equal as well. Right angle, or right triangle has one angle that is 90 degrees. An acute angle an acute angle is, or acute triangle, angle is less than 90 degrees. and obtuse is angle is greater than 90 degrees. So it would be this angle and that angle. The triangle inequality theorem is the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So basically, I'm just going to draw this out. You always have side A plus side B is greater than side C. Side B plus side C is greater than A, and side A plus side C is greater than B. A, B, C. The exterior sum or exterior angle theorem. The measure of the exterior angle at the vertex of a triangle is the sum of the remote two interior angles. So this is another one I'm going to draw out. So here's my triangle. Here's my exterior. This angle. This angle plus this angle will be equal to the third angle. So if I were to letter these, angle A, angle B, angle D, angle A plus angle B is equal to angle D. The incenter is then the center of the inscribed circle at the intersection of the angle. So basically, if I were to draw a triangle, like so, and I drew a circle, which is probably going to be pretty terrible, but you get the idea. Here to here to here, that would be my incenter. Okay, it's my circumcenter is when I draw my triangle and I have a circle on the outside of my triangle. It's the center of the circumscribed circle at the intersection of the perpendicular bisector of the sides. So again, here to here to here. The orthocenter is the intersection of the altitudes of a triangle. So basically, if you have a triangle that looks like this, you can break the triangle there, break the triangle there, you can break the triangle there, and right here would be your orthocenter. Your centroid is the intersection of the medians of the triangle. So that is very similar to this, the one above it, okay? So if we were to sketch how triangles are classified by their angles, simply you can draw an acute angle. Those are both acute angles. An obtuse angle. Like so. And then a right angle. For isosceles, these two are the same. A scalene no sides are equal, and then an equilateral. This side, and that side are all equal. So, when you have sides and angles, the triangle is the simplest polygon. 3 connected lines. There are 3 sides connected at 3 vertices, forming 3 angles. The basics of a triangle involve the sides and the angles. The triangle is also the building block for other polygons. A quadrilateral, for example, can be made of 2 triangles. So basically, you know what a triangle is. A quadrilateral can be made of 2 triangles. It's the building blocks. Building blocks of polygons. Okay. So then we have when you are describing triangles, we use a word that talks about the angles and a word that talks about the sides. This means that, for example, you would have a scalene obtuse triangle, because we know scalene means none of the sides are the same, but we also know that this angle is more than 90 degrees. And then you can also have a right isosceles. Because this is a 90-degree angle, but those 2 lines are the same. So it seems that with 3 possible words for angle and 3 for sides, there should be 9 possible triangles, but there are actually only 7. You can draw a right equilateral triangle? No. Try it. If you feel the sides are the same, so are the angles. How about an obtuse equilateral triangle? No. With an obtuse angle, the 3 sides cannot be congruent. We should note equilateral implies acute equilateral. Okay. So, if you were to identify the triangle below, it would be an acute isosceles. We have the 2 sides that are same and no degree above 90, or that is equal to 90. So, there's an important number, 180 degrees. That is the total number of degrees in a triangle. So if you do not know 2 of the angles, you can find the third, or if you do know 2 of the angles, you can find the third by knowing the total sum must be 80 degrees. So we know that all 3 angles, when added, must equal 180 degrees. So if you have we'll do an easy one. This is 90. This is 45. What is x? Well, you can do 90 plus 45 equals 135. 180 minus 135 equals 45. X equals 45 degrees. So, another practice. It tells you that you have a triangle. Here are your two sides, 42 degrees and 56. So 42 degrees plus 56 degrees equals 98 degrees. 180 minus 98 equals 82 degrees. That is the total of your third triangle. Concept D says if you know an interior angle in the triangle, you can find the exterior angle. So, exterior angles are supplementary angles to the adjacent interior. So basically, when we have our triangle, right, we have 51 degrees, we have 53 degrees, and right here we have 73 or 76. So we have 104 and 76 equals 180, so we know that is correct. If you do 180 minus this, 76 degrees, you will end up with this answer. So 180 minus 76 is 104. This is 104 degrees. There's your answer. Or you can do 51 plus 53, which also equals 104. That is still your answer. It will be the same whether you use these two or use this. So whether you use these two and do it this way, or you do that one and do it that way, it will be the same. So another practice. This one's a little bit more difficult because they're giving you this number and they're giving you this number and they want you to find A, which is angle C. Well, we know that 65 degrees plus A will equal 118 degrees. So, using all the information I'm given, now I'm going to solve. We have A equals 100, because we are subtracting. Subtract 65 from both sides. We have A equals 53 degrees. Okay, so it's just a matter of doing the work. So now we have the triangle inequality theorem. The triangle inequality theorem is the shortest distance between 2 points on a straight line. Then any other path between A, B, perhaps by a wave C, must be longer. That is, the sum of any two sides of a triangle must be longer than the third side. This is the triangle. So basically, it's saying if you were to draw, here's AB, right? And AB is 4. Or, oops. So here's A and here's B, right? And you're going to place C up here. A to C could be 4. C to B could be 3. You realize that this length has to be longer, or will be shorter than those two combined. So this length would be less than Okay. So if two sides of a triangle, 6 and 9, what is the possible length of the third side? So basically what they're going to tell you to do is the max possible. You're going to add your 6 plus your 9, which equals 15. Cannot be larger than 15 because those are your sides added. The minimum would be doing 9 minus 6, which would get you 3. Can't be smaller than that, right? Because when you add it together, it still has to be larger than the other two sides. So 6 plus 3 would get you 9. 9 plus 3 would get you 12. So you would write this as 3 is less than S, which is greater than, and S is less than 15. Okay, so now we have angle bisectors. What else can we do with a triangle that's 3 sides, 3 angles, and 3 vertices? We can add an extra line to show that certain relationships with angles, like cutting them in half, the line that we add is the angle bisector. It makes 2 congruent angles. So if I had an angle and I draw an angle bisector, it goes straight through the center. That means ABC is congruent to angle CBD. Your altitude. Your altitude is a perpendicular line from the opposite vertex to a side so that the angle formed is a right angle. So you see that here. Another way it could be drawn. Say you have an angle like this. Your altitude would be drawn here. Okay, and that would be your 90-degree angle. The center of a triangle. There are different points of congruency that are the intersections of angles, bisectors, perpendicular bisectors, medians, and altitudes. The line can be drawn through any of these points of congruency. The Euler line is like a line that contains all of these points and intersections. So basically, just remember your Euler line contains all points of these intersections. The intersection of the angle bisector of the angles of the triangle is the intersector. Incenter. It is the center of the inscribed circle. The circle is a tangent, so the sides of the triangle, the incenter is always within the triangle. So you have your triangle. You have your circle inside your triangle. It's really pretty terribly drawn. And if I were to draw lines from every angle. Here's my center, okay? The circumcenter is the same thing, but from the outside. So basically, I have this triangle. I have this very terribly drawn circle. When I draw my angles, this would be approximately the center of my circle. Remember, my stuff is not drawn to scale. Basically, what it does is creates a bunch of 90-degree marks, okay? The circumcenter, depending on your triangle, could be inside or outside. So if you had a triangle that looked like this, and your circle let's extend my triangle a little bit. My circumcenter in this case wouldn't be done like that. Instead, you would do it like this. So here's my circle, here's my triangle, right? My circumcenter would just be drawn like this, my center being outside of my triangle. You do not need to do this question or that question. And you are all set. Have a wonderful day, guys.